Hello data friends. Data Warehouse in Microsoft Fabric is a comprehensive platform for data and analytics, featuring advanced query processing and full transactional T-SQL capabilities for easy data management and analysis. Data Warehouse provides a relational database for large-scale analytics. Unlike the default read-only SQL endpoint for tables defined in a Lakehouse, a Data Warehouse provides full SQL semantics, including the ability to insert, update, and delete data in the tables. In this exercise, we load data into a Microsoft Fabric Data Warehouse using only SQL queries. So I have my workspace already created, mslearn-hub fabric. So now we are going to create a new Lakehouse and upload one file. So let's create new Lakehouse. So this is it, lab 06a. Create new Lakehouse, and I'm going to upload new file. I have my new file here already downloaded, so I'm going to upload this. So file is small, 3 megabytes, and we have this file here in the files. Great. Now we are going to import this file as a table. Okay, so file is uploaded. Now we are going to click these 3 dots here, load to tables, new table. Will be staging sales. That's the new name. Use headers, yes, and separator will be comma. Okay, we should be able to load this data from the CSV file to our newly created table in Lakehouse. Let's take a look how it goes. It should be finished in few seconds. Okay, table already successfully created. So let's check if we have the data appropriately shown. Waiting and waiting, over 1 minute already, which is not happy scenario. Well, this is not our lucky day. Let's try again after over 2 minutes. Not able to show that, so probably some timeout or something. But now we see that there's the data here in this table, in this small table. Okay, we have data. So now let's create a warehouse. It's not another warehouse, but we have Lakehouse already named like this. So maybe let's name it differently. And our warehouse will be created in few seconds. Let's create the fact tables and dimensions for the sales data. We will also create a view pointing to a Lakehouse. This simplifies the code in the store procedure and that we'll use to load. Now we have our warehouse. Let's click this new SQL query button, and in this new window, new tab, we will create some SQL statement. First will be create schema sales. The second, we will create the table. So let me explain you this. So we'll create a table in the schema sales called fact _ sales. Those are columns, But before that, before doing this, we'll double check if that table doesn't exist. So we are checking the system view where the name is fact sales. As you can see, this is the one. And if the table is in the schema sales. So that gives us the schema name using the schema ID column in the system view. Okay, so this actually checking if that table fact sales in sales schema exists. If not, it will create new one. Okay, so let's run this code to make sure it works. So now we should have the new schema and table fact sales. Yes, okay, we've got this. Okay, let's create new tab, and now this time we'll create another table, this time dimension, dim customer, and the same trick, we are checking if the table already exists. If not, we'll create it, and then here we will do alter table just to add the primary key. The primary key in this case for warehouse in Microsoft Fabric, those keys cannot be forced and validated. In other words, this primary key is only saved as some metadata for this table. And the uniqueness for this column is not enforced. That's why we need to use these keywords here, not enforced. Okay, let's run this. Now we should have another table, dim customer. Great. Let's create another one. And similarly, this will be dimension. This time will be dim item. 2 columns only, and primary key non-clustered, not enforced as previously. So let's run this, and we should have 3 tables in total. Great. Now let's create a view, as I mentioned before. So this time we'll create a view. Let's write this SQL staging sales as, and then it will be select from my Lakehouse, because I will be pointing to the Lakehouse that I created and uploaded some data from CSV file, as you remember. Lab 06, I think, a dot dbo dot, it was staging sales. Okay, let's run this. Yes, that's great. The view has been created. Let's check if we see this. Yes, we can see this. A new query. We can check if that view works and showing the data. So as you can see, we are directly loading data using view in warehouse, but loading data and pointing to from this view to the Lakehouse where the table already exists. Now that the fact and dimensions tables are created, let's create a stored procedure to load the data from our Lakehouse into the warehouse. Because of the automatic SQL endpoint created when we create the Lakehouse, we can directly access the data in our Lakehouse from the warehouse using T-SQL and cross-database queries. Okay, now next step is to create store procedure. New SQL query, we'll be creating store procedure named sales load data from staging, and 1 parameter, order year. I will explain you that later. Now let's open this store procedure here, and first thing we'll be doing will be loading data to the sales dim customer, so dimension of customer. So I will be inserting 3 tables. Let me copy that here. So they will be insert to the dim customer for those 3 columns. Okay, and then what is our source? Our source is let's select distinct from the same kind of customer name, and email address. Okay, in this for simplicity, we are pretending that customer name is our primary key. Okay, so that's why I duplicated this customer name here. And this the source is staging sales. So I'm loading this from the staging sales. Again, as you remember, this staging sales is the view from located in this data warehouse, yeah, but pointing to the Lakehouse. So this is what we'll be doing. And now I will be filtering by provided here order date, because only the data, all the data from the given year I would like to import to the warehouse. Of course, you can modify this as you want. Now, we want to protect ourselves and import only the data that doesn't exist yet, hasn't been imported yet before. Yeah, so that's why I'm checking here if the data doesn't exist, if the target record doesn't exist yet. Okay, so this is a very simple trick, not very performant, but it works. So for this demo purposes is enough. Yeah, so I'm checking dim customer where sales dim dim customer is equal sales staging, this staging sales, and the same, sorry, forget those customer name here, and the same customer name, and here this similar thing, but we are checking email address. Okay, so email address, please. So that's it. We are checking if the target record doesn't exist on the target table. So this should be enough to load the data for into the dim customer table in sales. The same thing we are doing for dim item. So insert into sales dim item, and the same trick. Okay, item ID, it's without underscore, and item name. And again, as I said, the same trick we'll be doing here. So I pretend that the item name is my primary key, so that's why I set the same column twice. Okay, from sales, staging sales, where the same thing here and not exist. So let me copy that to speed up the process of developing the code. And not exist. This time we'll be looking at, so our target is this here in this case, so in here will be this item where, of course, where sales dim item name equals sales dot sales staging sales item name. Okay, so in this case we'll import only new records, even if we execute this store procedure twice or more times. Now at the end we'll import data to the fact table, which is fact underscore sales. So let's insert into sales fact underscore sales, and the columns are, so all those columns here, and then select the same column we are doing cast here to convert the types, the same for order date, because as you remember, we are importing data from CSV, so we might not have all the appropriate and correct types. In this case we have, because during the import from the CSV file, the process was smart enough to identify based on some top rows the appropriate data types, but for any case we are going to cast or convert these types to the correct target types. So date, int, float, and float again here, and from sales staging sales year. In this case we are not going to check if the target record exists, so if we run this twice it will duplicate the records in the fact sales. Why we're doing this here? Because fact tables are generally big. Those are big tables, and we shouldn't run the same load, the same ETL process for the same partition or the same set of data, because checking if the target record exists will impact drastically and decrease the performance of this load process. Okay, now we have this insert into here. I think we are able to execute this and create store procedure. We have invalid column name, item name. What is that? Let me check. Item name, because it's not item name, it's item, it's just item. Okay, so we need to correct this and correct this as well. Customer ID, it should be probably this. Yes, now we have store procedure created. Let's check. Yes, we have our store procedure created. Now let's execute the store procedure. So I will copy that name, create new query, and we'll be executing the store procedure with parameter 2021. Let me run. It means, you know, we are loading data for this particular year. Let's run. And now the process is loading data from Lakehouse, from our staging sales table, to the warehouse. Okay, the process is finished. We see that almost 30,000 records has been imported to the fact tables, 117 to the second dimension table. The second one was item, dim item, and over 10,000 records for customers. So let's check any data from those. We have some data for customer, which is great. And we should have also data for dim item, dimension item. And there's, let's check, it should be 117 records, which is true. Let's run some analytical queries to validate the data in the warehouse. So new SQL query, and let's start with select. We'll be selecting from first from sales fact sales. We'll alias this as a S and join this table to sales dim customer, which will be C, joining on those columns, customer ID and sales, the same customer ID. Okay, now what kind of columns? Customer name, and let's say we'll summarize unit price times quantity, and this will be our total sales. Okay, so we have this, we have two columns actually, and we need to do group by. Yeah, group by customer name, of course, and let's sort this out by total sales. What else? I can add optionally, of course, because all my data are from 2021, but I can filter by order date to 2021. Let's see if that works. Cannot be bound as order date. What else did I miss? Yes, so that's the correct one. And now we see the data grouped by customer name. And for example, if we like to check if I have any other data from other year, which should return us 0 records in this case. Yeah, this is true, so it means we loaded only the 2021 year in terms of data for sales. Now let's modify this query a little bit and group by dim item, so items from item dimension. As you remember, we have item name, so dim item, so here should be item ID, and this is our sales, this is our item, so let's rename the alias as well, and that should be item ID. And sales, this is the same, we need to change back to the 2021, and item name. Okay, so the other parts remain the same, so let's check. See item, yeah, so I just miss one small thing. Where's the C? It's this. We have alias I. Now should be fine, and we have the same analytical query but grouped by items. Now let's write another query here. So let me maybe create new, and this time will be the query will be with CTE expression. Okay, so this will be our first part of CTE. Okay, we are doing some transformations here on fly, and we are checking if the item name is like contains helmet word, then the item or category will be helmet. The same for bike and gloves. So we are naming some categories. If any of those will be true, then the category name will be other. And then we are getting the customer name from customer dimension and calculating the total sales. So we are getting the data from fact sales, joining to the dim customer and joining to the dim item, and filtering by year 2021. Okay, now because this is CTE, we need to start with keyword, categorized sales as. Okay, and this is our first part of query. The second query in the CTE will be this. So will be ranked sales as, and here I will copy paste that because we don't want to write everything from scratch and wasting time. So here we have select category, customer name, sum sales, total sales, row number over partition by category, order by sum of sales, and that would be our sales rank from categorized sales, where category will be one of those three. Yeah, group by category and customer name. That's it. That's not the end, because this is the second part of the CTE. We need to actually at the end execute the correct query. So it will be those three columns from ranked sales, where sales rank equal 1, and ordering by total sales. Okay, that's our query. Let's run this now. And as you can see, we have a customer name by each category and the total sales on the top from the rank. In this exercise, we have created a lakehouse and a data warehouse with multiple tables. We ingested data and used cross-database queries to load data from the lakehouse to the warehouse. Additionally, we have used the query tool to perform analytical queries. I know this was a very simplified example of how to load the data to the data warehouse. In the future videos, I will show you the real scenario of loading the data with both methods, full and incremental. So stay tuned. Is there any other topic you would like to learn? Let me know in the comments below. Also visit Microsoft Fabric community website, link below also, which is a phenomenal knowledge hub for this product. In the meantime, thanks for watching and have a fantastic day, and see you next time.